look at exponential growth and decay. Okay, so you'll want notes, you'll want to write this down. It's not terribly hard, but there are some pieces and some formulas in here you need, so make sure you do have something out and you're writing this down. Okay, and when we're looking at exponential growth and decay, we actually have a formula that we're going to use. And the formula says y equals a, and then in parentheses, 1 plus or minus r to the power of x. Okay, this exponent being an x is what makes it an exponential, right? When we were graphing exponents in our e-learning yesterday, everything had this exponent of x. Okay, so the x and y are going to stay. That's what makes it a function. We need those to be there. The a value is going to be our initial value or our sort of starting value. The r is going to represent our rate, but that rate needs to be a percent. We'll sort of talk about that in a minute. That's in decimal form. Okay, so our rate is representing, our r is representing our rate. We're just turning that percent into a decimal. Okay, and then the plus or minus doesn't stay as both of them, right? When we were solving quadratics, we had a plus or minus because we had two options. We don't have two options today. We need to decide if we want to use the addition sign or if we want to use the subtraction sign. And we'll use addition if it's something that's growing, if it's growth. And we're going to use the subtraction if it's decay. So if it's getting larger, the value is growing, we're going to use the plus sign. And if it's decreasing or shrinking, then we're going to use the subtraction sign. Okay, so when we look at these, I'm going to use this word, so don't freak out. We're going to be looking at some basic story problems. Yes, story problems you're going to have to read. But it's very similar to quadratics, where we're just going to sort of take that basic information and then turn it into just sort of the appropriate places in the equation, right? So we're using that same formula, and then we're just going to plug in sort of the numbers we need from what we read. Okay, so let's say we have a bank account. Let's see, Amanda today is going to have a bank account. And in her bank account, she is going to have $5,000. And it's going to earn 5% each year. Okay, so this is a little bit stretched because most bank accounts aren't going to earn this amount unless it's a specific type of account where you have a large sum of money in it. But just to sort of simplify it and to stick to numbers that aren't quite as huge, we're going to have $5,000 and it's going to earn 5% each year. Okay, so first, let's write an equation that will represent this situation. So to write an equation that will represent this situation, we're just going to go right back up to this formula. So we're going to say y equals, okay, A is going to be the initial value. So the initial amount in her bank account is $5,000. Then we're going to put 1. Now we have to decide, is this growth or is it decay? Well, since it's earning money, right, the value in the account is going to be growing. It's going to be getting larger. So if it's going to be getting larger, we want to add, and it's going to be getting larger at a rate of 5%. So 5% as a decimal, right, we're moving that decimal 2 places to the left. So it's going to be 0.05. all to the x. Now, we could leave our equation in this format. Technically, we have written an equation, but we can combine that stuff inside the parentheses. So 1 plus 0.05 is 1.05 to the x. So that will represent That's the equation that represents our situation. Okay, so now maybe we want to calculate what it's going to be a year from now. Okay, so maybe if we want to calculate what it's going to be a year from now, and 2 years from now, or 3 years from now. Okay, if we want to get a picture of how much money is going to be in the account over the next 3 years, so we could do 1 year from now, 2 years from now, 3 years from now, right? This is going to allow us to calculate and sort of see a picture of what's happening with the money in the account over the next couple years. So what you want to do is use your calculator. And very similar to yesterday, right, we're just going to be plugging these values in for X. So in my calculator, I'm going to type in 5,000. Then in my parentheses, 1.05. Up caret to the first. Okay, and I'll get out $5,250. So that means after a year, my bank account now has $5,250 in it. Okay, so maybe if I want to see after 2 years, okay, my bank account will have I don't have enough space on my screen, sorry, $5,512.50. Right, I can arrow up and change again if I want to calculate 3 years. So I'll get $5,788, and then this is money. So I can't do 3 decimal points when I'm talking about money, so I'm going to round, so 0.13. Okay, so this says if I put $5,000 into this account and I just let it sit there and it's earning 5% interest each year, after 3 years, I will have earned an extra $788.13, right? I'll now have $5,788.13 in the account. Now, obviously making a table for every single year isn't necessarily practical. So maybe if I want to know how much the account will have in 15 years, right? I don't need the entire table. I can just use that same formula and plug in 15. Okay, so in 15 years, I'll have $10,394. And what, let's see, we have to round, so 64 cents. Okay, and that's how we'll work with exponentials, representing them as an equation, and then calculating some values for future years. Okay, so we might have something similar. Let's see. Tony has $700 in his bank account. This is also going to be ridiculous, but I want to point something out here. And it is going to earn .1% each month. So if we want to write an equation that would represent this, we would say y equals, A is our initial value, so 700. Okay, again, it's increasing in price. So we could say 1 plus, now 0.1% is going to be 0.001. Oops, not on my Promethean board. Okay, so if we add those together, we'd be here. Now we have to be careful because this is talking about months. So if I now want to calculate how much Tony's going to have in his account after 2 years, right? How much will Tony have in 2 years? We're going to have to deal with the fact that the information that's given to us is in months, but the question's being asked of us in terms of years. which means we don't want to plug 2 into our equation because 2 will represent 2 months. So if we want 2 years, we're going to calculate how many months that is, right? There's 12 months in a year. So we will have to plug in an x value of 24. So if I say 700, 1.001, and I'll do up caret to the 24. Okay, after 2 years, he would have $716.99. Okay, there's a couple more situations that I want to look at. It really isn't any more complicated than this, but just other key terms I want to make sure you're aware of and getting that set up correctly. And then what happens when the percent isn't obvious. So let's say you're going to purchase a new car and your new car costs $25,000 and it depreciates at 2% each year. Okay, this is no different than what we were just doing, but we need to make sure we understand what this type of term is telling us. So we're going to still say y equals, our initial value is 25,000. Okay, our percent is still 0.02, but now it's depreciating. Okay, depreciate means that it's decreasing in value. Likewise, appreciate means that it's going up in value. So if you read the word depreciate, you need to use a subtraction sign here. It's going down in value. And you need to be really careful when you're checking your math here. My students often miss that decimal point. And so when they turn this into the correct equation, this should be a 0.98 to the x, right? 1 minus 0.02 is 0.98. So this would be the equation that represents it. I could do all of those same things that I talked about in the first problem, right? I could make a table of what the cost of the car is going to be over the next 5 years. I could tell you what the cost of the car will be 20 years after you buy it, whatever. Okay, then finally, let's say we have a basketball. This is like going to be student impact basketball or something. Okay, so a basketball tournament has, let's say maybe it has 300 teams. And we are going to have half eliminated each round. Right? If we want to write an equation that represents this, it's still the same formula. Okay, so we're still doing y equals, our initial value is the 300 teams that are playing. Okay, they're eliminated, so it's getting smaller each round. The problem is that we don't see a rate. We don't see that percent immediately jumping out at us, right? But what's happening is right here, half of them are eliminated, right? Half as a percent is 50%. So here when we go to plug that in, this would be a 0.5 or a 0.50, right? You'll have to change that wording, right? If a quarter were eliminated each round, then we'd be using 25%. And so this will actually get an equation of y equals 300 times 0.05 to the x, right? You could just put a 0.5 here. I just wrote that wrong. So what you're going to do is go through, there's 2 problems in the worksheet that's attached. And then just like always, the short Canvas quiz to answer a couple of the questions. Make sure you submit that for attendance. Otherwise, fingers crossed. Hopefully I will see you all on Monday and we will go from there. Have a great rest of the day, guys.